Hello, welcome to Unit 5, Lesson 6, Analyzing Graphs. The learning objectives for this lesson is to be able to use graphs to compare and contrast situations that involve exponential decay, and to use information from a graph to write an equation that represents exponential decay. So again, we're focusing more on that exponential decay, and we're going to really dive deep into different situations and looking at graphs and writing equations that could represent the decay. We're going to go ahead and skip activity 1 and move on to activity 2. Let's take a look at activity 2. So it says the value of some cell phones changed exponentially after initial release. Here are graphs showing the depreciation of two phones 1, 2, and 3 years after they were released. So you have 5 questions that you need to answer. So go ahead, pause the video, and answer those questions. All right, question 1, which phone is more expensive to buy when it's released? So to figure out that question, we're going to look at the y-intercept. So we can see for phone A, the y-intercept is 1,000, whereas for phone B, it's 840. So we know phone A is more expensive. Question 2, how does the value of each phone change with every passing year? So if we look, we can see that phone A is depreciating more quickly than phone B. You didn't have to get into specifics for this one. And for those who don't know what depreciating means that you're just losing value. So when things are purchased, they often will depreciate. They will lose the value. They will not be as worth as much. So if you recall with the last lesson, we had the car that was depreciating. Well, here we're talking about cell phones depreciating as well. Let's take a look at question 3. So this one says, which one is falling in value more quickly? Explain how you know. So we already discussed how phone A is losing value more quickly. And the way that we know that is if we look closely at how much it loses. Phone A goes from $1,000 to $400 in the first year. So that means we have a loss of 400 out of 4,000, which is 2/5, which is 40%. So we see that the first year, the phone is 40% of the original value. The second year, it loses $240, which is still that 40%. So we know that it's losing 40% of the value each year. Phone B, on the other hand, loses $210. So that's 210 out of 840, which is 1/4, or you could say 25%. So we know that phone B the phone is 25% of the original value. So we know, therefore, that phone A is losing its value much more quickly. Question 4 says that the phone continues to depreciate by the same factor each year. What will the value of each phone be 4 years after its initial release? So for question 4, we need to figure out the growth factor. Now, in the previous problem, we were calculating how much it was losing by. Remember, growth factor, we want to know what the current value is. So to figure that out, so for phone A, you can look at it a little bit, 2 different ways. If you know that it loses 2/5 of the value, we know that 3/5 remain. Or you could set up a fraction of using year one's value over the current value, and we see that that is 3/5. So we know their growth factor is 3/5. And then same thing for phone B. Again, if it loses 1/4, you could say that the current value is 3/4. Or you could say, you could take the current value, 630, or year one's value, and divide it by the original value, which was 840, and you would get 3/4. Then from there, to figure out how much the phones will cost in year 4, all you do is take year 3's value and multiply it by the growth factor. So we have 216 times 3/5, which is $129.60. Whereas phone B, we're going to do 3/4 times $354.38, which is approximately $265.79. So again, you need to make sure you're using the correct growth factor, because you want to talk about the one that is talking about how much value is staying with the phone, not how much it's losing. Question 5 says, for each cell phone, write an equation that relates the value of the phone in dollars to the years since release T. Use V for the value of phone A and W for the value of phone B. So if you recall, we always take our initial amount, which is 1,000 for phone A, multiply that by the growth factor, which was 3/5, and then that's being raised to the T power. For phone B, our initial amount was 840, growth factor was 3/4, and that again is being raised to the T power. The key thing to remember for this problem is that when we are looking at the differences between the two graphs, which one depreciates more quickly, it's important to know that we can't just simply subtract the consecutive numbers. We should be dividing the value of one year by the previous year to determine the growth factor. Once we have that growth factor identified, you can then write the equation to predict the value of the phone for a later time. Obviously, we've talked about mathematical models and how technically this would never reach $0, but realistically, it probably would reach a point where the cell phone's not really worth much or anything at all. All right, let's take a look at the next activity. So this next activity is a card sort. So go ahead and go onto the Canvas homepage, download the card sort document. What you will need to do is match each graph with its situation. So go ahead, pause the video, and work on that. All right, so here are those cards. We have 4 situations and 4 graphs, so let's take a closer look. So first situation says the value of a company's stock doubles approximately every 4 years. The relationship between the number of years since purchasing the stock and stock value. So if I know that the company's stock is doubling every 4 years, I need to make sure I look really closely at the graph to make sure that I'm looking for every 4 years. So let's take a look at the graphs. I know it's not card 3 because that's an exponential decay problem. This one it could be, so let's take a closer look. My initial value is 100. If it doubles every 4 years, my 4th year should be 200, and I see that it is. Let's just check one more time just to make sure that it does indeed fit with the pattern. So if it's currently 200 in year 4, by year 8, it should be 400, which I see that it does match. So I know that card 1 and card 7 are matches, 1 and 7. Let's look at card 2. So card 2 says a card loses its value, loses a quarter of its value every year after its purchase. So if it loses 1/4 of a value, the value that remains, the growth factor, is going to be 3/4. So let's see if we can figure out which of these graphs go with 3/4. If my initial value here is 1,500, if I take 3/4 of that, I would get 1,125. And looking at this point, it looks like it could be that But let's just double check the other graph just to make sure. So here, this is definitely not 1,125 because it falls below the 1,000. So I know that graph 2, or graph 3, matches with card 2. So 2 and 3. Let's look at card 5. Company value of a company stock triples every 8 years. So now I'm going to be looking at the every 8 years to make sure that it's tripling. So there's only one other exponential growth, but let's just double check to make sure that it is indeed matching up. So 6, 7, 8. So if the initial value is 100, in year 8, it should be 300, which it is. So I know that card 5 and 4 match up. And then obviously the last two cards will match, but let's just double check just to make sure we're understanding how to look at the graphs. So it says a laptop loses 2/5 of its value every year. So if it loses 2/5, that means the growth factor is 3/5. And if we go down to card 8, if we do 1,500 times 3/5, we get 900, which we do see that year 1 is $900. So our last match is card 6 and 8. So the key things to remember here is that for those exponential decay problems, making sure that you're identifying the correct growth factor. The growth factor is always going to be the value that remains, not what it loses. So if you see that term loses, that's not going to be your growth factor. You're going to have to do an extra step to figure out the growth factor. We could even go a step further and write equations for this, especially for card 3 and 8. So if our initial value is 1,500 and our growth factor is 3/4, our equation could be, we'll say D equals 1,500 times 3/4 to the t power. And then same thing for card 8. Again, we could say D equals, this time, 1,500 times 3/5. 3/5 to the t power. For the two exponential growth problems, it's a little bit more difficult because although it's growing, it's doubling and tripling, that's not happening every year. So those aren't technically growth factors. Growth factor is what it would be from year to year. So we don't know. We could figure it out, but we don't need to do that for this problem. So that's it for this problem, or this lesson. You guys have the rest of the time to work on your cool downs, and if you finish your cool down, go ahead and try to do some practice problems as well. Thanks for watching.